So in this video, we're going to discuss parallel and perpendicular lines. We're going to talk about how to write the equations of these lines, and we're also going to talk about a few problems on your practice test here. And recall, parallel lines have the same slope, and perpendicular lines are said to have opposite reciprocal slopes. We will see that shortly. We will visit that idea shortly. But first off, I want to talk about how to write the equation of a line in general, given that there is a point that lies on it. So right here, we see the point x1, y1 lies on our function here, y of x. It lies on this line. If we're wanting to write an equation of this function, an equation has an equal sign. What we do is we write it as m. M is the slope of this line times x minus our x coordinate plus whatever our y coordinate is of that point right there, plus y1. What we can do is we use this equation right here, this very important equation, and we can represent the equation of this line in slope-intercept form using this result right here by distributing the m. We will see how to use this equation here with these problems. So for question 1, what we're trying to do is we're trying to figure out what the equation of this line is way down here. We're trying to write an equation for that, g of x. But we're given a line, kind of cuts it right here. We're given the equation of this line is f of x, and it's said to equal 3x plus 2, 3 being the slope of this line right here, 3x plus 2. And we're also given a point on our function g of x here, as well as these lines are said to be perpendicular to each other, because this is also given here. So it's 90 degrees, and this point right here is 9, 4. So we're given a lot of information. We're trying to figure out, again, what g of x is, what the equation of that line is here. So whenever I think of how to solve parallel and perpendicular line problems, I think of in context of slope, first off. So we're trying to write the equation of g of x. We write an equal sign because equations all have equal signs. And we're thinking of slope, first off and foremost. The slope of two perpendicular lines are said to be opposite reciprocals of each other. So right here we see the slope of f of x is 3. Opposite of refers to opposite, meaning a minus right here. So we're going to write g of x is equal to minus, and reciprocal means the reciprocal of that number, of that slope right there, is just 1/3. So we're doing the opposite reciprocal to figure out what the slope is right here. And then what we're going to do is the same thing that we were doing earlier. Remember, the x minus whatever the x coordinate is of our point. So we're going to write 9. Again, this point is contained on g of x. So you go x minus our x value plus our y value of that point. And from here, it's just algebra. G of x is equal to distribute the negative 1/3. So you get negative 1/3 x. Don't forget to distribute it to the negative 9. So we're going negative 1/3 times a negative 9. Two negatives yield a positive number, so we're going to get a positive. And we go 9 divided by 3 is just 3. So we're at plus 3. And then don't forget that plus 4 right there. So plus 4. And we're not done quite yet. 3 plus 4 is just 7, so I can get rid of that 3 plus 4. Let's just represent that as plus 7. What we see here is that the equation of our line, g of x, is just that. In slope-intercept form, we see mx plus b. So that's how you do number 1. Remember, perpendicular lines, their slopes are said to be opposite reciprocals of each other. For number 2, it's a little bit different of a question. We're still trying to figure out what our function g of x is here. We're given a point that lies on that function right here. It's said to be -3, 7. And you're also given another function right here, f of x. And that function is said to equal -4x plus 2. Both of these functions, both of these lines right here, are said to be parallel to each other. So these lines are also, so we know that they are parallel to each other. This is also given right here. These lines never touch. We're wanting to figure out what the equation of g of x is here. So we first write g of x. It's an equation, so we write an equal sign. Now, what we think of next is, what about slope of parallel lines do we know? Parallel lines are said to have the same or equal slope. So right here we see the slope is -4, so I'm going to write a -4 right here. They have the same slope, these lines have the same slope, -4. And then we go times x minus an x coordinate that lies on this line right here. So I'm eyeballing an x coordinate right here, so it's minus a -3. That kind of looks funky, but we go like this. So we go x minus our -3 right there, and then we write plus our y coordinate of that point, so plus 7. So in other words, we see two negatives right here. So we're going to, instead of writing minus a -3, let's just change that to a plus 3. We can do that. So let's write x plus 3. We're going to do the same thing we did earlier. We're going to distribute the -4. So we get -4x. -4 times 3 is a -12 plus 7. So in other words, g of x is equal to -4x. -12 plus 7 is just really -5, so we're going to write -5 right there. So the equation of this line, g of x, our function, written in function notation, functions referring to that right there, would be that. Again, we see m is our slope, -4, x minus 5 is b, mx plus b. I'm going to erase this right here. The next question is a little bit different. This question is number 3. It said that a vertical line contains the point 4, -7. And it's wanting us to figure out what is the equation. What's the equation of this line in particular? That's what the question is. Now, in order to do this, what we do is I always draw a picture. Geometry problems I find so much easier with a picture. So we're given some kind of information right here. We're given some kind of number, so we're going to probably use that information right here. And I'm going to draw an x and a y axis in order to kind of represent this point better, to see what's going on here. So we're given the point 4, -7. So we're we're looking at our graph right here. We're going to eyeball about where that point is on our graph. So we see 4, -7, so we're going 1, 2, 3, 4. We go count 4 units in the x, and then we go -7 units in the y direction. So that point would be somewhere about, let's call it right down here. So we're given that point is 4, -7. Now, a vertical line contains that point. In other words, that means that a vertical line must pass right through that point and must go look like that. And it's vertical, so it's up and down. Now, we're trying to figure out what the equation of this line is here. And in order to do that, what I always think of is what is consistent about this line right here. What are my x values or are my y values consistent? And by that I mean, if I take another point, just an arbitrary point on this line right here, what is consistent about it? Well, let's see this x value right here. It is just 4. What must be the x value of just another point on that line? Let's say that point right here. What is our x value right here? It didn't shift anywhere in the x direction, so our x value must be 4. So the x coordinate of that point must be 4. What about this point right here? What is our x value of this point? Our x value is also 4. What about here? We're going 4 units out to the right. Our x value is also 4. Our x value for this line at any point along it must always be 4. So that kind of leads to the equation of a line right here. It's a vertical line, so our x value is always 4 on this line, so x must be equal to 4. So that is the answer to this question right here. Our line is just x is equal to 4. I hope this helped.